Okay, so let's start with our daily meeting. Today I will start backwards. I will start with Theodorus.
I think he's on leave today.
Okay. I saw that you changed this. Thank you. Avi, hello.
Yes. Yeah.
I accept your merge request. I don't know if you see it.
Yes, actually, yes. Thank you. Actually, I've been working on this issue, and I made one small change on a new branch for this issue. There was a problem with recognizing the Nvidia runtime. So for that, I have created another branch from this issue and updated that onboarding script. So if you scroll above, if you scroll above, I have mentioned the change.
Okay.
This particular the missing runtime configuration. So this one I have updated in the onboarding script. So during the onboarding process, this file would be created automatically. So this issue won't be there after. So if we try to run any job on Nomad after onboarding a GPU, we would be able to do it successfully.
Okay. And I think after our meeting today with PG, we will be able to split or add more details to this task.
Yes.
Okay.
So I have tentatively given some durations, but after discussing with PG, it would be better to further revise it later.
Sure.
Thank you.
Okay. Hola.
Yes, good afternoon. For my side, I was working with Avi not Avi, Santosh, to complete the build of the dev files, and we are happy to say that it was successfully done. So now what I have to do, or what I've just begun doing is try to integrate what he did into our build step. So do you need the link to the dev file? It's over here.
Yes, it should be good.
So so afterwards I am continuing the work on our unit test. So that was why I have not written a work breakdown structure, because I wanted to see how the whole coverage reports will be integrated with GitLab. So, but before the end of today, I will fill up this work breakdown structure because I've completed my research in that aspect. So, and that's where I am so far. So, but finally, perhaps before Monday next daily, I would have finished creating all the developed branches for all the necessary repos.
Okay. So this issue is almost done. It only needs to update all the projects, right?
Yes, that's correct.
Okay. So I will maintain it on the doing, okay, on doing column. But I know that it's just question. It's just a need to copy what you did in all the
Yesterday's
projects.
tokenomics. Yep.
Okay, but we will need to stay with it in the doing because it's not complete. Okay, but I know you are already working on this with Santosh, right?
In fact, about this one, based on what Kabir was mentioning yesterday about rather than us using semantic versioning, we just stick with a
Unity.
simple tag of dev stable and release
Okay.
for each branch. Maybe that semantic versioning task might not progress.
Okay. Okay. So when you are finished with this copy to all the branch, you please change this task to the review, okay, and pick one of these to the doing. Okay.
Yes. Correct.
Thank you.
Thank you, sir.
Jitendra, please.
Yeah, so I've completed the things at my end, and I've pushed all the changes also in the greatest status here. Maybe you can change from doing to review it,
Okay.
and maybe you can assign the issue to me as well.
And which issue you are going to work? I don't have any in the backlog yet.
Actually, after that one has been reviewed, I'm going to create another one. I've been going through his work
Okay.
to specify the next one.
Okay, thank you. Santosh?
He's out today as well. I think he posted it.
Okay.
But I
so
mentioned that he's been able to make the dev build successfully, and is now in the package registry.
Okay.
Santosh, anything?
And Safi.
So I'm done with the API specifications. I'm uploading the YAML file right now for async API, but my internet is a bit wonky, so it hasn't uploaded yet. It should be progressing and should be here in a minute.
Okay.
I can share my screen and show you the.
Yes, please.
So these are all the operations for the Tokenomics API, all the operations that I could think of right now. So if I scroll down here, there should be open channel. So here we have the way I did it is I thought of the API as being blockchain agnostic, like it doesn't care about what blockchain it's working on. So the channel type would tell us what kind of contract it should interact with. For example, if it's just a one-time payment, then it should be an escrow. If it's a subscription or pay as you go, it would either be a payment channel or a state channel, depending on further R&D. So there's a slight difference between a payment and state channel. So a payment channel is it's a simplified state channel. What a state channel is basically you would have a contract and multiple signatures. Multiple people would sign one transaction for it to transfer. I would explain it more in detail, but that might take a while. There's closed channel. If the expiration ends and you want to extend the expiration, then it would be this. And there's a lot of event listeners. So we would listen for a withdraw event, deposit event, verify event. This verify here. So deposit would mean you deposited something in an escrow account. Withdraw would mean you withdrawed, you taking it out. Verify would mean you're making sure that if someone has set up a subscription or a pay to compute channel, you can verify to make sure that the funds are secure, that the funds are in the smart contract. So that way, the trust is outsourced to the tokenomics API, and both parties don't have to trust each other. They would trust that the tokenomics are fair. So this would either return true or false, depending on the payload that we provide. So again, this is you would open a channel, you can close a channel, and extend a channel. The other things are listeners for events that happen based on these pub events. So you can subscribe to whether these events have happened or not.
Okay. Okay. On Monday, we will have a meeting
Right.
and we can go through it and discuss a little bit more with Kader.
Sure. I've also I've also prepared like a presentation to explain payment and state channels, because I do believe that might be a bit confusing. So that I'll share in the technical discussion.
Okay. Okay. We just need to talk to Khaled to finish the daily meeting, and we will start the technical discussion after that. So, Khaled,
Yes.
I found this issue in our backlog.
I can't see the
don't
screen.
No, sorry. Yes, sorry.
It's all right.
Are you seeing now, right?
Yeah.
Okay. I found this issue in the backlog. I didn't finish listen your meeting with Kabir and Ram, but I just assigned this because Kabir mentioned something to deal with etcd cluster.
Yeah.
I don't know. Could you read it, please, now and see if it's related to what you are doing?
Sources an organization in a group share an etcd cluster. This etcd is not public and needs to be accessible by other daemons. The etcd source channel allowing users to be reused for different sources of the organization. I think it's similar to what we're doing. Yeah.
Okay. So I will maintain this issue. I will add it to the doing, and we can add or modify the description as you wish, and I will do it also after finish the listening of the meeting.
All right, but I think Kabir mentioned that we need Drum to help us with that because like I think he knows the problem better than anyone. So could you like
okay.
Yeah. All right,
Sure,
good.
sure. Kabir and me will do that. So, okay.
All right, thanks. So this is assigned to me now, yeah?
Yes, but
Right, good.
we will work in the description
Right.
to do it more clear.
All right.
So we are finished with the daily scrums. Anyone wants to add something to the daily meeting? Okay, so let's start the technical discussion. Safi, do you want to start? Okay. We will be showing some videos explaining what some developers are doing in their issues. The point is to share knowledge about the NuNet works and how where we are going through. Okay, so Safi, could you start? Could we start with you, please?
Sure. Is my screen visible?
Yes.
Right. You guys can still see it, right? So I made the presentation so I don't forget about the stuff that I was going to talk about. So this is not going to be very long. So I have no intention to bore anyone. So just a brief overview why the things that I'm going to talk about are blockchains, payments over blockchains, problems over payment, why the payments can become the way that payments happen over the blockchain can become a problem. How do we scale blockchains? What the tokenomic API is going to look like, and what are the three finance models that we're going to be using. So we're currently only the only two blockchains that we're going to be looking at is Cardano and Ethereum. Cardano has a extended UTXO model, and Ethereum works off of proof of work, right? So and Cardano has proof of stake. Now, I'm assuming that most people are familiar with these protocols, and I don't believe that this is going to be. If you're not, it doesn't affect the rest of the presentation. But I won't go too deep into it because it'll take too much time. Okay, so the main problem that we're gonna be addressing is payments over the blockchain, and the biggest problem is the time it takes for a transaction to complete. So a transaction on Cardano can be as short as 20 seconds. However, to make sure that a transaction is safe, the transaction needs to be like 13 or 15 levels, block levels deeper, which could take 5 to 10 minutes to complete. Payments over Ethereum could be as fast as 15 seconds to anywhere to 50 minutes, depending on the gas fee and network congestion. So Ethereum has well, gas fee also depends on network congestion, because if there's too much network congestion, then we have something called gas wars, where people will pay more to have their transaction go out first, but someone will always try to outbid you for their transaction to go first, and then gas fees soar, making Ethereum very, very expensive. So the problems with doing on-chain transactions, especially in our use case, in NuNet use case, for all the services that for these decentralized services, is we would have potential bottlenecks. Waiting for example, if if we're paying per computation, how much computational resources we're using, it's not fair for the compute resource to have to wait 10 minutes for one transaction, or the one who's buying the compute resource to wait for at least 10 minutes for one compute let's say one computing resources to finish, and then send the money. So that compute resource could be doing something else in that time, or could be doing the next step of the computing problem, whatever it's working on, rather than waiting for the transaction to complete. Transactions can and often do fail. So I've had this problem with the Polygon Harmony multiple transactions. Sometimes there's a problem, especially if you're sending out multiple transactions and you're not keeping count of something that's called the nonce. The nonce is just the identifier of the sequence of transactions that are going through. If you don't keep account of that, transactions, because they go in a sequence. If that sequence gets messed up, the transactions start to fail, and that can, especially if let's say you have an NFT marketplace, right? And you want to sell, you want to take fiat currency and against your NFTs. So that those NFTs are going to be stored away in a wallet. Once the transaction for your fiat currency confirms that this guy has paid $500 for the NFT, and then you transfer the NFT. The problem here, this is going to be a sequential transaction. So there's a likelihood that that transaction fails. So there needs to be a fallback mechanism, which especially if there's network congestion, then that can take ages to resolve. So that 10-minute transaction, now imagine if transactions are in a queue, one transaction takes 10 minutes. The last transaction, if there are 5 transactions in the queue, will take 50 minutes to resolve. So that's one problem that can happen. And gas fees can be very high when there's a lot of network congestion. So when there's a lot of people using the blockchain, then the transaction fees will soar, as mentioned earlier, right? So there are 2 main ways that we work around this. One is we wait for when we get the lowest gas fees, when we schedule a transaction for when the people in the Western world are sleeping. that's usually when the gas fees are the most low. We schedule a transaction then, and we execute it then. But in our use case, that is infeasible, and in most use cases, that is infeasible unless you're doing something with the trading bots or something. So the other thing is something called a payment channel. So what a payment channel is basically it's analogous to what a check is in a banking system. So what a check is, when you sign a check, you can cash it before a certain date, right? So a check can be valid for 3 months, and if you haven't cashed the check by 3 months, it's not valid anymore. Similarly, a payment channel between 2 nodes can be valid for a certain amount of time. After it's expired, you cannot cash it in anymore. So the good thing about payment channels is that you can do transactions off chain. So essentially what happens is you would deposit a certain amount of money into a smart contract and sign that transaction, sign a hash of that transaction, and give that signed hash, especially on the Ethereum bot, give that signed hash to someone else to like, hey, here's the hash. You can redeem this from the smart contract at this date, and they can go and redeem that smart contract at that date. What that does is, especially if it's an ongoing transactional relationship, in that same payment channel, you can send multiple tokens back and forth without having to worry about gas fees, because the transaction is essentially, they just need to redeem that transaction, which makes it way faster. And the other thing are state channels. So state channels, payment channels are simplified state channels. So that multiple parties, when they come together, so there's something called a multi-sig wallet, for example. That's one example of a state channel. What a multi-sig wallet is you have multiple people that own one wallet, and once all parties sign off on a transaction, that's when a transaction happens. When everyone agrees that this transaction should happen, that transaction happens. So Hydra, the Cardano's, it is a layer 2. It essentially what Hydra does. So the layer 2 scaling solution for Cardano. It creates these state channels that allow for scalability on Cardano's nodes, right? So hold on. You guys can see my screen, right? Or just this, or just the slides.
I'm seeing the slide. No, actually, all the screen. Sorry.
Okay, you can see the entire screen, right?
Yes.
Right. So here's an example for the Plutus code on Cardano. So
Oh, no, sorry. Sorry. I am seeing a title presentation. Click to
okay.
add title.
Right.
But I was seeing all the tabs, so I thought I was
Okay.
seeing all the all the screen.
Okay, I think now you can see the entire screen, right?
Yes, Pluto's background playground. Okay.
Right. So okay, so a Pluto script has three parts, right? No, it has two parts. It has a on-chain part and a off-chain part right here, right? So the on-chain part, this is what is known as a validator. So in each, what happens with let me just write a comment. So we have a UTXO, which is an unspent transaction. Okay, an unspent transaction output. So what happens here with this is we have something called a datum and a redeemer, right? And then we have a transaction, right? So, and this transaction could be towards anyone. So what a datum is basically the data that's associated with the transaction, right? So this is a type datum, the data that's going to be in the transaction, the beneficiary of this payment, and when they can redeem this payment. There are some caveats to how you can set time in Cardano, but we'll not go into that because that's a bit too, well, not very technical, but that's not very relevant. So the way that validator works is, and this is the context of the script. So the way of the validator works is it'll take, hold on, right? It'll take these two variables right here. They're declared here, right? So this is declared in a functional manner. They'll take these two variables and check whether this is true or not. If these two variables are true, then the transaction goes through. Otherwise, it does not. So it already fails even before the transaction goes through. We can tell whether this transaction is going to be valid or not. The off-chain part is where, the off-chain part is, oh, I changed the code, so I gotta compile it again. One second. Right. The off-chain part is what tells the wallet what to do. So we have a deposit function, which is obviously we're going to be depositing certain ADA and giving it a certain deadline to work. And then there's a withdraw function, which we can use to withdraw funds at certain point in time, right? So if I go here, you can see it's the wallet. If I add a wallet, it already knows that there's a deposit function and there's a withdraw function. And then you can deposit here, evaluate, and okay. I think it's my internet. That's can you guys hear me? Am I audible?
Yes,
we can hear you. Yeah.
Okay, this usually happens when my internet mess. Yeah. Okay, let's just assume it worked. Let me go back here. Yes, it is a Pluto's playground does weird things. I don't have it. I have the local version running. Okay. Anyways, can I move this? Okay. So this is the payment channel in. Apologies, one second. So this is a payment channel in Ethereum. So the way that this is going to work is, then this is just a quick overview. So the way that this is going to work is we're going to deposit funds, right? And then we're going to sign a hash. The hash is basically going to be this payment method here, right? So there's the difference here is in Cardano, there would be a UTXO that we would go and redeem, right? So let me just go back into the code. If you go here, right? So there's an unspent output at the, here we're gonna, here. So the source address, this ledger script address, is basically the contract address, right? So there's an UTXO existing at the contract level, which we can redeem here. It looks up or looks at the all the UTXOs and looks for the condition that we defined, and then it transfers. It should be here, right? So it looks at the beneficiary. If the beneficiary matches in, for the UTXO and the deadline, it'll send the funds out, right? Here, it's a we're doing a similar thing, but we have this structure which we turn into a hash here, this metadata. We turn into a hash here, K256 hash, which then we sign using the user's private key. And this signed hash, if this signed hash right here, once we have the signed hash, we can then, by giving the metadata and the signed hash, decode that signed hash, recover it, and see if the message sender is the same guy that's if the it's the same guy that signed the transaction, right? So if this matches, the signature matches the message sender address, so we know that this is for a fact been signed by the correct. So basically, this is correct. The signature is signed by the correct person. That's stored in this metadata, and then we can check if this value has this metadata actually exists in our balance book or not, and then we transfer the payments. So this is the simplified version of how it's going to work. If I can just go, if I can just find it, that'd be very nice. Here it is. Okay, so the way the Tokenomics API is going to work is going to be blockchain agnostic. And what that means, it's not going to care about the underlying blockchain. Or depending on the payload, here, for example, depending on the payload, the to address and from address, we can know what blockchain it is because of the address length, or we could just add what blockchain you want to send a transaction on in the payload, and we can open those payment channels here using the Tokenomics API. And there are two ways that we can go about it. Is we can build our own payment channels, at least for the public alpha. We can definitely do that because the use case is not going to be as big. They might not be as efficient, and then we can eventually, once we figure out the other payment channels, we can migrate we can plug and play those payment channels along with our payment channels as well. So it'll be much more modular that way. Yeah, that's I think that's
Okay.
for the entire overview.
Okay, please, Umer.
Safi, I have a question here. Like in
Sure.
the start, you mentioned that there were basically 2-3 issues. One issue was that the person has to wait for a particular time period, so he cannot use his resources to earn something, and
Right.
the issue was the gas fee. So then we shifted to this tokenomics API and basically the payment channel and the state channel.
Right.
And then state channel gives that person UTXO something. So basically in that particular UTXO as well, when he is going to redeem that, he's going to require some time, right? So
Right.
and also there will be a gas fees with particular that transaction. So how are these problems getting solved using the
Right.
payment?
Well, then it can be done asynchronously. Otherwise, then you'll have to wait for the transaction to clear and keep trying until it's done. So the way that Radium does it is that they have the way that Radium is also a payment channel that works on Ethereum. The way that they do it in their smart contracts, you have to deposit a certain amount of money upfront, and as long as your transactions do not exceed the amounts that you've put in upfront, the the payments pretty much work simultaneously, if that makes sense. So the tokens are already in the smart contract. They're not going anywhere. The address to which who the owner is for those tokens, that's being changed. Does that make sense?
Yeah, so that does not involve any gas fee, right?
It involves gas fee, but it'll be less. It won't be as much.
Okay, and since the transaction are asynchronous, so it will be fast. He doesn't have to wait for that particular time.
Exactly.
Okay, sounds good.
Okay, any more questions to Safi? So thank you, Safi. Your presentation was very useful. Thank you.
Thank you, Safi.
Thank you guys for hearing it.
No, it's our pleasure. Who does want to go next? Avi, do
Yes,
you want
can I
to?
go next?
Yes, please.
Okay. Can you see my screen? Okay.
Yes.
Okay, so basically this is a very small presentation about the implications of secure boot on NuNet onboarding. So just a small introduction. So what is secure boot? Basically, it is a verification mechanism. Whenever computer will run some device drivers, it will look for some signatures. If it is not signed, then it won't allow the driver to be loaded. So that's what I've experienced while onboarding GPUs on one of my laptops. I noticed that secure boot was enabled by default. So if you search this on Google, like secure boot enabled by default, if you search the exact phrase, you will notice that since Windows 8 was launched since 2012, so there were all the laptops and OEM-based systems, desktops and laptops, all were having secure boot enabled by default. So this poses some problems which I'm going to discuss. So just a second. So from the Debian documentation, initially the non-Debian based distros, they provided support from very early on, and Debian was a bit slow in getting it working. But right now we have full support for the secure boot. So now we have UEFI secure boot support to make things easier. So this particular screenshot is from a Windows notebook. This is actually my dad's laptop. So it is also having Ubuntu installed as dual boot. So am I audible?
Yes.
Hello? Okay. So this is, as you can see, I have marked in red, secure boot is state is on. So it is, I noticed that it is enabled by default. I just wanted to do a random check on a laptop. So I found that it is enabled by default. But there were no problems when I installed Ubuntu on this laptop. So basically, the thing is, the laptop is running fine, Ubuntu is running fine, but the proprietary Nvidia driver is not installed on that. It is running the open source driver, so it is working fine. So these points that I've made here, this means that all OEM-based desktops and notebooks came with secure boot enabled by default. And our primary approach was when there was no support for secure boot, our first instinct was to disable secure boot by going to the BIOS and then going for installing Linux. but later on, they have provided support and there is no need to disable it from the BIOS. So how does this relate to NuNet? So the issue is GPU drivers on secure boot enabled systems require a machine owner key, also called as MOK, during the onboarding process. So whenever we are installing the GPU driver, it will ask for confirming a password twice. So after completing the driver installation, the user must reboot and he has to manually select this enroll MOK option. If he doesn't select it, and if he just keeps it unattended, what will happen is the continue boot option will be selected automatically, and within 10 seconds, it would boot to Linux, and the driver will not be loaded because he did not enroll the same password that he entered during the driver installation. So this poses a problem. So this is the screen that you'll notice after rebooting. And this is what I had. This is the main issue I discussed here. So basically, first, so the system with secure boot is enabled by default, and when driver installation happens, it will set a password and is confirmed twice during setup, and the system reboots. If the user manually enters the same password, he is successfully able to onboard the GPU. If not, then it will be a failure, and GPU onboarding will fail in that case. So basically, I've done a small change on the script. So what it is basically I'm installing the MOK utility via the script. So what I'm doing is I'm doing a secure boot check. I'm storing this value in this string inside a variable called secure boot check. And I'm also using a substring, which is stored as the value enabled is stored in here. So I'm checking whether the string enabled is stored in the larger variable, which is if secure boot is enabled, the outcome of MOK util SB state would be secure boot enabled. And if it is disabled, then it would be secure boot disabled. So this would happen only on systems which have secure boot in their UEFI systems. But the older motherboards, they don't have it enabled. They don't have that feature actually. So in that case, if I just run a command, I'll just run a command here. MOK util. This system is not having secure boot. So the message is if EFI variables are not supported on this system, that means it is not using secure boot. There is no secure boot in this system. So basically what happens is, so what I've done here is I've given this after checking for that information. If it is enabled, then I'm giving some alert messages to the user for just a minute and giving him an opportunity to read this message. So I'm guiding the user that if you don't enter the password during the reboot, this installation will fail. Yes, on this one. I created one video actually. Yeah, this one I had made one small video. Just a second. Yeah, so this is the script I had. This is the snippet. I'm just making it executable so that I can run it. So this was run on my laptop. This is having secure boot. So within a minute, it will just resume the installation. In this case, it will just go to the prompt. I just forward it. Yeah. So I manually checked also whether secure boot is actually enabled or not. So I'm running the same command manually. So secure boot is enabled on the system. So this was. So this will run only on those systems where secure boot is enabled. If it is not enabled, then that section will be skipped. So the question is this only a GPU driver use case? So definitely not. Any third-party driver would require secure boot signing. So perhaps we should. I wanted to notify our developer community about this. So basically, there might be an issue if we may come across in future if we are running any third-party driver on secure boot enabled systems. So the signing procedure can be manually repeated also. If an user is unable to do that operation, that ABCD steps that I've mentioned there. So the user can manually run the command to update secure boot policy with the flag enroll key, and then he can repeat the process. So the Debian documentation also has a small description about this package. So basically, this is what the secure boot system is all about. Thank you.
Thank you, Ali.
Thank you.
I think this work showed how important it is to us to set up a pipeline and also create packages for different systems and distributions. So we can see problems like this one that you saw while you are testing the onboard script in your issue.
Yes. So this I tested it on both systems. So one is having secure boot, one is not having secure boot. So
yes.
I showed you both the differences actually.
Yes.
Yeah.
Thank you.
Thank you.
Yes, Omer.
Yeah, I wanted to ask a question regarding
yes,
MOK.
Yeah.
Is this MOK a password that is set on the boot menu, or is it something else?
No, when you will install the driver, during that process, during the installation, it will ask to enter this MOK as a password. It will be confirmed twice, and when you will reboot, you will be shown that this screen. I'll just share once again. Yeah, can you see the screen? Just a second. Yeah, can you see?
Yes, I can see.
Yeah, so this is the screen that will be shown on the next reboot after installing the GPU driver. So the automatic process is it will directly go into the booting the system. So if you do not manually select this enroll MOK option, which is the second one, then what will happen is it will fail to load the driver.
So every time user has to do this enroll MOK, and it will ask for a password.
It is the only one-time process for the GPU driver installation.
Okay.
Yes, only once. Yes.
Okay.
Okay, thank you. Yes, Dagi.
Just one question. I missed when you showed the script. Can you share it with on the dev channel, or maybe show it again?
Yes, I will share.
Okay.
Actually, just a while, 2 hours ago, it was merged on the develop branch.
Okay.
Yeah. I will share it.
Thank you.
Okay. Okay, Khaled, do you want to show your work in the SNet service, running the SNet service?
Well, actually, I already did on the video included on the channel, so I think it might not be necessary.
Okay. Okay.
Right.
Thank you. Does anyone want to share something with the team? Okay, so I want to share. I sent you in the dev channel a link to this page, the Git Workflows. But before going through that, I would like to show you that we are creating wiki pages in the documentation repository. Okay, we have this team process from Malloc. These Git workflows that I want to talk with you. The Tokenomics API. Did you? No, we will add the Safi works on Tokenomics API in this page after we concluded. Umer is working in security coding guidelines. This will this page will show it. We will discuss it with the team after Umer's task that he is working on. This page was did by the marketing team to request for private testers to NuNet, and technical discussions Nada created this page to add our meetings about technical discussions, as it said. Okay, so just to let you know that we are documenting and document our process and our work in this repository documentation wiki. Okay. About Git workflows, I sent this link in the dev channel. I don't know if you read it, and I would like to go through it because it's important to our process of using the Git. Okay, this first part has a developer view. I think you all are doing that, but it's good to check. And this part we will be talking about our branching strategy. Okay. So these Git workflows from developer view shows how we should update code to the GitLab. Okay. First, when a developer wants to do some code, obviously it is related to an issue. So we need to create a branch from the issue that the dev is working on. Okay, this is a picture from GitLab to show that we can create a branch or create a measure request from an issue. Here I am in a page of an issue, and in this button we can create a branch or an issue. Okay, this is the way that we choose to start a branch. Okay. Before continuing, we did this workflow, but you can discuss it. Okay, I am presenting it to you, but you can comment. We can change it. Okay. Okay, moving on. A branch tends to be short-lived because it's about an issue, and an issue should be short. Okay. When the developer is gone, he commits. Oh, not when he's gone. We encourage to commit, push every day, and write good commit messages. So when the developer is done, he will create a merge request and assign reviews. Dagin and me, we will be default reviews, but the developer can add anyone else that he thinks is good to review the work. Okay. A merge request will trigger a pipeline, a CI pipeline. This is already it's already working in our pipeline, but we will need to add more stages in the pipeline. This is the current OLA work. Merge request can be changed during the review. Review should leave questions, comments, suggestions. GitLab has a good tool to do that. And each update in the code during the merge request will trigger the pipeline again. Once the merge request is approved, okay, I'll talk about that here, but mainly the dev is working in a branch from an issue that we call feature branch. And the feature branch, after the merge request is accepted, the code goes to the develop branch. Okay. And when the review approve the merge request, this merge will be done automatically by the GitLab, and the other branch, the feature branch, will be removed from the GitLab, and the code goes to the develop branch. When the code goes to develop, the CI pipeline runs again, and it will, I think it will not be common to have problems at this stage when we merge the feature branch to the develop branch. But if we have problem, so the pipeline or some in some further tests, we will see it, and we will need to change the develop branch to make things work. Okay, here is when probably Dagin and me will be going the mesh. We will check to delete such branch and to squash commits. Squash commits is something that's discussable. Some people like it, some not, and we can see what we prefer in NuNet. Okay, so this is our workflow from developer point of view. Anyone has any questions or comment about this workflow?
Yeah, actually, I have one question.
Yes, please.
Yeah, actually, I tried to create a branch once from one of the issues. So I when I was trying to when I wrote develop on after the branch name would be automatically selected, but when I was writing develop in source, and I was seeing that
okay, it's not.
yeah.
Sorry, I know that. It's because we didn't create the develop branch to all repositories, but Ola will be doing this week, the next week.
Okay,
that's
thank you.
Because that. Yes.
Thank you.
Anyone? think that I think it's what we are already doing, except for the develop branch, we was using just the master branch, but it's most likely the way that we were already working, right? Okay, if anyone has further comments or would like to discuss it, just let us know, okay? Now about the branching strategy. So as I said, we have feature branch that are created from an issue, okay? And we will have more than one feature branch at a time. Mainly one branch for developer, probably. And when an issue is complete, there will be a mesh request, and the mesh request, when the mesh request is accepted, the code goes through the develop branch. So when you are going to create a mesh request, the mesh is to develop, okay? Let me see. Staging branch. Staging branch is the branch that we will be using to test the modules, the NuNet modules. Okay, we need to have this staging branch because the develop branch is more dynamic. The dev team is working on, and the develop branch will be updated frequently. But when we need to do some tests or tests with user, or when we need to create a release, we need to work in a fixed code. We can't work on this test while the things are changing, right? So we have the staging. We will have the staging branch that is basically a view of the develop at a certain point of time. This branch, this staging branch, can be modified if we saw a bug or improvement. Okay, this staging branch it can be modified. And when the staging branch is okay, when the tests are finished and the code is approved, we will mesh actually probably the pipeline, but we don't have this yet. But probably we will have a stage in pipeline that we say that the test in station is complete, and we will mesh this code again in develop, and it goes to the main branch, meaning that it can go to production. The main branch will have the code that is in production, and it will be tagged with the release name, version. Okay, about this version, we have these labels, and the first number means a major version with compatible API changes. So we change this first number when we have big modifications that makes the code incompatible with the old version. The second number is a minor version. It's a functionality, and it's compatible with the last version. And the third number is to hotfix. Hotfix, when we are running a code in production, when we see a bug or something that's needs to be done in a fast way, it's critical, we create a hotfix branch from main branch, fix whatever it needs to be fixed, and when it's approved, the codes go to the main branch, creating a new release, and also to the develop branch. So we the team can work with the new code, the new fixed code. Okay, every update in a branch should be done using a merge request. Okay, I think that's it. Does it make sense? Do you think that is a good strategy going through that? We have already discussed a little about this in our meetings, right? Ola, Umer also participate and again, but we are open to comments. Okay. If anyone wants to comment something after in the dev branch, oh, sorry, so much brains in the dev channel, you can do it anytime. Okay, this is a work that we are creating this, and this is not right in stone. This is not right in stone. We can change our process, our strategy. So feel free to comment if something could be better. Okay. And anyone wants to say something? Okay, so I think we finished. Thank you for all to listen and participating.
Thank you. Thank you, Janine.
Thank you. Bye-bye.
Bye.
Bye. See you.
See you.